Good morning. Today we are going to do 4-1 properties of exponents. We are going to start off with the zero exponent property, which says any number raised to the zero power is always 1. So whether it's b to the 0 power, 6 to the 0 power, 1 million to the 0 power, doesn't matter. Anything to the 0 power is 1. The next property is the negative exponent property, which states that a negative exponent means I need to change the position. So if it's on top, I need to move it to the bottom. If it's on the bottom, I need to move it to the top and change it to a positive. We cannot have a simplified expression that has negative exponents. So for example, if you see 5 to the negative 6, that means I write 1 over 5 to the 6th. Radical roots property just means that any radical can be written as an exponent as 1 over whatever the radical is. So if it's a square root, it would be it would be b to the 1/2. If it was a cube root, it would be b to the 1/3. So if you see the fourth root of 32, I can rewrite that as as this 32 raised to the 1/4 power. The product property, so when I multiply numbers that have the same base, I'm going to add their exponents. So 5 to the 3rd times 5 to the 4th. So I'm going to take 5 to the 3 plus 4, which is 5 to the 7th. So I keep the base and add the exponents. The quotient property, when I divide, I keep the base and subtract the exponents. So if I have 3 to the 7th over 3 squared, that's going to be 3 to the 7 minus 2, which is 3 to the 5th. The power of a power property, anytime I raise a power to another power, means I multiply. So 7 squared, all raised to the 3rd power. I keep the base of 7, and I'm going to do 2 times 3. So I get 7 to the 6th. The power of a product and the power of a quotient are basically I'm distributing the power to everything inside. So for the product one, if I have 5m squared raised to the 3rd, well, this 5 in there is raised to the 1st. If it's not there, it's to the 1st. So that'll be 1 times 3, so that'll be 5 to the 3rd. And then 2 times 3 for m, which is 6. From here, I can figure out 5 to the 3rd is really 125, m to the 6th. The quotient one, so I can distribute. So if I have 5/3 all raised to the 4th power, that means I have 5 to the 4th over 3 to the 4th. So I can figure out what those are. I get 625 over 81. So from here, we are going to go ahead and look at some examples. So for example 1, I am going to evaluate each expression. So the first thing I'm going to do, I see a root. I am going to move that up to the exponent. So this becomes 125 all raised to the 1/3 power. Well, when I see 125, I know I can rewrite that as 5 to the 3rd. And now power to a power says I can multiply. So I keep the base. 3 times a 3rd is just 1. So my answer is 5. I'm going to do the same process with b. First thing I'm going to do, I'm going to move it to the power. So 1 over 32 raised to the 1/5. Next, I'm going to realize 32, I can rewrite that as 2 to the 5th. Here, I need to take this 1/5 and distribute it to both of them. So I get 1 to the 1/5, and 2, 5 times 1/5 is just 1. Well, 1 to the 1/5 is 1, so my answer is 1/2. On to the next part. 9 to the 3/2. So I look at 9, and I know that this 2 down here in the denominator really means square root. So what I can do is I can think what number squared would get me 9, which is 3. So 3 squared is 9 raised to the 3/2 power. So now I have power to a power I can multiply. 3/2 times 2 is just 3. So I get 3 to the 3rd, which is 27. And finally for this section, 8 to the over 27 to the 2/3. So I realize when I look at this, 8, I can rewrite as a power of 3. 27, I can rewrite as a power of 3. So I'm going to do that. So this becomes 2 to the 3rd over 3 to the 3rd, all raised to the 2/3. So I can distribute that to both of those. I end up with 2 squared over 3 squared, because 2/3 times 3 is 2, which gets me 4/9. So now we are going to take these rules and we're going to go a little more into the variables and the abstract. So when I look at this first one, I see x cubed over x to the 5th. I know that division really means subtraction. So first thing I'm going to look at is where do I have more? I have more on the bottom because that's a 5th power. So I'm going to leave my answer on the bottom. So it is going to be, they're all going to go away from the top. 3 minus 5 leaves me with just 2 left on the bottom. Right, you could have also written it as x to the 3 minus 5, which would get you x to the negative 2. We can't have negative exponents when we simplify, so I would have had to move that down to the bottom. So either way you do it, you will get the same answer. On to B, we are going to put a 1 by the 5 because that's 5 to the 1st. And I'm going to go ahead and distribute that. So I get 5 squared, because when we raise a power to a power, we multiply. 3 times 2 is 6, so that's x to the 6th, y to the 8th. The only thing I can do is figure out what 5 squared is. So that is 25 x to the 6th, y to the 8th. Just like anything we've always done, we still have to follow order of operations. So the first thing I'm going to take care of is that exponent. So this exponent outside the parentheses needs to be distributed to all of these in here before I do my multiplication. So I'm going to bring down the first parenthesis. And then I'm going to distribute that 3 to all of them. When I do, I'm going to make sure I put my negative 2 in parentheses. Otherwise, I could get a wrong sign. So 3 times 3 is 9. B is 4 times 3, so that is 12. So now we are going to simplify this first. So the first parenthesis comes down. Negative 2 to the third is negative 8. So here we're going to multiply our big numbers. So 3 times negative 8 is negative 24. I'm going to add my exponents. So my a's combined, 2 plus 9 is 11. My b's combined, remember when there isn't an exponent, it is understood to be 1. So 1 plus 12 is 13. So let's continue on with some more complex examples. So when I look at D, first thing I notice is I have an exponent on the outside. I need to distribute that to everything on the inside. So power to a power, again, I multiply. So this is x to the 6th. 4 squared is 16. Y squared is just y squared. Here I'm distributing the 3. So we have x to the 12th, y to the 6th, and z to the 3rd. When we multiply fractions, we multiply straight across. So on top, I have an x to the 6th and an x to the 12th. When I multiply, I keep the base, add the exponents. Y to the 6th just comes along. On bottom, I have nothing alike, so they're all just coming along. You'll notice in my answer right now, I have y's in 2 positions, one on top, one on bottom. I have more on top, so they're going away completely from the bottom. 6 minus 2 is y to the 4th. So my final answer is x to the 18th, y to the 4th, over 16, z to the 3rd. Looking at E, same process. First thing I'm going to do is distribute the exponents out front. So this has an exponent of 1, so I get negative 3 squared, x to the 4th, y to the negative 6th. In this parenthesis, I end up with x to the 15th, y to the negative 10th. So we're going to combine. This is all multiplication, so that means we add exponents. So negative 3 squared is a positive 9. X to the 4th and x to the 15th is x to the 19th. Y to the negative 6th and y to the negative 10th is y to the negative 16th. Okay, it is not simplified yet because I have a negative exponent. That means just the thing with the negative exponent is going to change positions. So I end up with 9x to the 19th over y to the 16th. On to F. Same process. First thing I'm going to do, distribute. So I end up with a to the negative 4, b to the negative 2, c to the negative 6. They're all negative. That means they all need to switch positions. So c to the 6th comes up, a to the 4th, and b to the 2nd goes down. I can't reduce anything. That is it for that one. So when I look at G, again, first part of the process is we're going to distribute that exponent, even though it's negative. So that means I have 5 to the negative 3rd, x to the 12th, y to the negative 9th. On bottom, I have 2 to the negative 3rd, x to the negative 6th, y to the 3rd. So anything that has a negative exponent is going to switch positions. So if it's on the bottom, it's going to the top. If it's on the top, it's going to the bottom. So this all becomes 2 to the third, x to the 12th, and x to the negative or positive 6. On bottom, my 5 to the negative third needs to move to the bottom, so that's 5 to the third. Y to the third stayed there, and y to the negative ninth moves down to the bottom. So now I can simplify. 2 to the third is 8. 12 plus 6 is 18. 5 to the third is 125. 3 plus 9 is 12. Okay, next we are going to go ahead and notice we now have roots. So in order to find or do square roots with variables, we need to rewrite imperfect squares. So everything has to be rewritten in perfect squares when possible. So we know what perfect square numbers are, but perfect square variables means I have an even exponent. It means my exponent is divisible by 2. So when I look at this one, 36, that is a perfect square. So that is fine. I don't need to rewrite it. I just bring it along. X to the 4th. 4 is divisible by 2. So that is perfectly fine. I'm going to rewrite it. Y to the 7th. That is not divisible by 2. So I go down 1. Y to the 6th. Is that divisible by 2? Yes. So I rewrite y to the 7th as y to the 6th times y. Because when I add the exponents, I still get 7. So I have all my y's there. I'm just rewriting so I can simplify them better. So here we go. Square root of 36 is 6. That comes out. Square root of x to the 4th. 4 divided by 2 is 2. So that's x squared. Square root of y to the 6th. So that's going to be y. 6 divided by 2 is 3. This y to the first does not have an even exponent, so it has to stay inside. So there's your final answer. When I look at I, first thing I'm going to do is combine them down into 1. I'm going to do the division. So 20 divided by 2, 40 divided by 2 is 20. For the x's, remember it's x to the 3 minus negative 2. That's what division means. So that ends up being x to the 5th. Y, same thing. 2 minus negative 3 is y to the 5th. And z just comes along. So now we're going to rewrite as perfect squares. The biggest perfect square that divides into 20 evenly is 4. So I'm going to rewrite that as 4 times 5. X to the 5th. That is not divisible by 2. So the closest one that is 4. So how many more x's do I need? 1. Y to the 5th. Again, that's not divisible. Y to the 4th is, and I need an extra y. And z, there's only one way to write z to the first is z. So I'm going to take everything out that's a perfect square. Square root of 4 is 2. Square root of x to the 4th. Remember that means I keep the letter, divide the exponent by 2. So I get squared. Y to the 4th. That's y squared. Everything else stays inside. So it's 5x, y, z. And there's our answer. So now we've done squares, let's look at some cubes. So just like we did with perfect squares for perfect cubes, we are going to rewrite imperfect cubes. That means our exponents are going to be divisible by 3. So 32 is not a perfect cube. So I would find the biggest perfect cube number that divides into 32 evenly. And in this case, that is 8. So 8 times 4 gets me 32. 6 is divisible by 3, so that's fine. Y to the 17th is not. So then I go down. Y to the 16th. That's not divisible by 3 either. Y to the 15th is, and how many more y's do I need? I need 2 more, so that's a y squared. Because remember, they still have to add up to 17. So let's take out our perfect cubes. The cube root of 8 is 2. Cube root of x to the 6, so 6 divided by 3 is squared. The cube root of the y to the 15th, 15 divided by 3 is 5. The rest have to stay inside, so we have the cube root of 4y squared. On to k. Again, perfect cubes, so I need to figure out what numbers in 81 is a perfect cube. So 81 is 27 times 3. 13 is not divisible by 3, so I go down 1. 12 is, which means I need an extra x. 21 is divisible by 3, so I just leave it as y to the 21. So 27 is going to come out as a 3. X to the 12th, 12 divided by 3 is to the 4th. 21 divided by 3 is y to the 7th. And then what's left inside is 3x. And there's your answer. Last one. So we've done square roots. They had to be, your exponents had to be divisible by 2. Cube roots, your exponents had to be divisible by 3. So for fifth roots, my exponents have to be divisible by 5. So I find the biggest number that I can divide by 5 into 18. So this becomes the fifth root of x to the 15th, and then I need 3 more, so it's x to the 3rd. 32 is 2 to the 5th. So this is divisible by 5, so that comes out as an x cubed. This is divisible by 5, that comes out as a 2. What's left inside? So I have the fifth root of x to the 3rd. That is it for this lesson. If you have any questions, please let me know.